get started with the last mock technical interview of the day, which is we have a Leetcode with Ty. Is it Ty? Is it pronounced Ty? T?
T, just call
T?
me
Okay,
T.
T. Sounds good. All right, so let's get right into it then. Is there anything you want us to know before we get started, or do you want to get right into it?
Um, yes, so hi, I'm T. So I'm currently a senior majoring in computer science, and I'm actively seeking for software engineer role, new rad in 2025.
Awesome. Cool. Thank you for sharing. So let's get into this first question then. So I'll read the problem statement, and you're free to ask any questions as we go. So in this problem, we're going to be merging intervals of numbers. So I want you to write me a function called merge intervals, and you're going to accept a list of intervals, and you will return a list of intervals. Okay.
So for the input, it will accept um, a list of interval,
Yes.
right? And for the output, um, so it will returns um, list of merged interval.
That,
Is that
that's right.
correct?
And so now an
Okay.
interval is defined as a pair of numbers. Okay, pair of numbers.
Okay, so okay. So this would be a pair of numbers. So let's say if we have 1, 2, and then 2, 5, and then we will have another 8, 10, and then 10, and then we will have 12, 15. So this would be our input. So for the output, also we need to return a list of the merged intervals. So um, the output would be 1, 5, and then 8, 10, and then 12, 15. Is that correct for the output in this case?
That is one of the correct answers. Another correct answer is that keep
Okay.
in mind the order does not need to be sorted.
So the orders in not sorted.
Yep. So you can
Okay.
return, and keep in mind that also means that the input is not sorted. So you can
Okay.
return in any sorted order.
Input is not sorted. Um. Okay. And um, for the HK, one more questions for the HKs. So do we have like an empty list of intervals like this, right?
No, interval must
So,
an interval must have two numbers.
okay, let's have two numbers. Okay. Um, in another case, um, so what if we just have the interval maybe 2, 3, and then we just return 2, 3, right? That would be only one interval.
Yep, that's right.
Um, and also, so can we have the interval, for example, um, so like a duplicate interval like this, um, in this
Yeah,
case.
that's valid.
Okay. So in this case, we just return only one, which is 2, 5, right?
Yes, that's correct.
Okay. Um, so I think the first approach that I have is that first we would need to um, sort the intervals. Um, so I would need to sort the interval according to their starting time in ascending order. And next, I will iterate through each of the interval in the interval list. So so one we iterate through each of the interval in the interval list. We need to check if the n times of the previous merge interval is greater than or equal to the start time of the next interval, then we're gonna merge them together. So we need to check if the n times of the previous merge intervals is greater than the start time of the current intervals. And we just merge them together. Otherwise, then we just append the current interval into the merge list. So otherwise, merge the interval into the merge output. And we just need to return the answers. So does this approach make sense to you? And can I start coding now?
Can you just describe exactly what sorting the interval means?
So I think so. In this case, since if we have the interval that's they're not sorted in orders, so here we would have to sort by the start time, right?
Sorry, there's no
So let's
there's no
say
times. Do you mean like the lower bound?
um yes because we would have the interval. Let's say we have the start time. It would be, for example, it would be 1, and then the end times
Oh, okay,
it
so you're
would be
saying they're
2.
times.
So we
Okay,
just
yeah,
sort it.
yeah, yeah, yeah. We can use word time. That's
Yeah,
fine. Okay.
yeah, yep. All right. So let me have a function that called merge interval, and it would take in an input at an interval list. First we need to sort the interval. So since we need to sort it in the start time, so sort start time. Next, we would need to iterate through each of the interval in the interval list, right? This would be the start time and the end times in the interval. And then we would need to, I think we would need to check. So I forgot to initialize a results list, which is store the merged interval. So if the result list is empty, right, then we would just append the current interval into the answer list, and then we would need to check for the previous interval. So that would be like this. and if the previous so previous interval greater than the start time, then we just need to take we just merge them together. So previous interval and then the end time of the current interval. So, and then otherwise we just append the current start and end time. So this case, this would be not overlap interval. And then in the end, we just return the answer list, which is the output of the merged interval. So
Okay.
let me just run, yep,
So no, continue.
let me just run through yep, yep. So let me just run through the example here. So first, we will need to sort the list of the intervals according to their start time in ascending orders. We would need to iterate through each of the interval in the interval list, and then we check. So is the current answer list, if it is none, then we just append the current interval into the answer list. And then, so for this case, it will check the previous end time of the interval. Let's say now, our answers would have, so now we currently at the first interval, which is 1, 2, right? And then this one, it would check the last birth interval in the answer list, which is 1, 2, and then this will accept the end times. This will accept the end time of the last merge interval. And that it will compare that with the current start time in the interval. So if it's greater than or equal to the start time of the current interval, then we just need to merge them together. So, right at this line, then we just merge the interval 1, 2, 2, 5 to 1, 5. And and then next we would need to go to the next interval, and then we check the start time and the end times. So in the end time of the last merge interval, which is 5, is a not greater than the start time of the current interval, which is A. So we just append the current start time and end time into our merge interval list. So we would have A10 now, and then it will go to the next interval, which is 12 and 15, and then it checks. So the end time of the last merge interval in our answer list, if it's greater than the current start time or not, it's not. So it will go to this else statement, and it's append the current interval start and end time into our answer list. So yeah, in the end, we just return the merged sorted intervals.
Okay.
And yeah, okay. So does it make sense to you?
Made sense so far, but there's a bug if the first value of the pair is the greater value. Can you fix that?
if the first um if the first pair is the greater
If the
value,
first value of the
you're
pair is a
saying,
greater value, and the second value of the pair is a smaller value. Yes.
so what if we have um 3 and 1s,
Yep.
right? Okay. So if we have the 3 and 1, and then we have 1, 2, and then 2, 5. Um, so in this case, if we had 3, 1, 1, 2, and 2, 5, so the merge of the list is would be um, then okay. If it is greater, and the order you said that is the not matters in the end for the output, right?
Yes, the end of what doesn't matter, but it does have to be the smallest set of pairs that describe the full interval. So you have to actually merge them if they are overlapping. If they're
Okay.
not overlapping, then you don't have to merge them, of course.
So if that's the case, then we merge the 3, 2 together, right? Um, and then the 2, 5, and then so if the 2, 5, then we also merge them together. So it would be 3, 5. So this would be our answers in this case,
Uh,
right? Is that
no, in this
correct?
case, the answer would be 1, 5. Because 1, 5
1,
encompasses,
5.
because the 1, 5 encompasses the full range.
Okay, I see. So this would be okay, okay. I see, I see. So if that's the case, then um we would have to sort the first interval 3, 1. We have to sort it to 1, 3, right?
Yeah, that's one way to do it.
And isn't it so my code here is sorted by the start times. So um so here is in this line is already sort the interval 3, 1 to 1, 3 in this line, right? Um, I don't know if I'm understand that
Yeah, so
correctly.
if you had this being 1, 3, then your solution would work. Because 1, 3 and 1, 2 would merge to 1, 3, and a 1, 3 to 2, 5 would merge to 1, 5.
Yep.
But it's not 1, 3, it's 3, 1. So that's the difference. So how can we get that to become
3,
1, 3?
1. So we will need to swap. We will need to swap the position of the end time to the start time, right?
Yeah, you could do that. You could
So
swap it and then sort it. Yeah, you could do that.
um, swap the time times with start times, and then sort it. So if that's the case, then I have to I think I have to change the sort a little bit. Let's see. Okay, I think if that's the case, then we need to check if our intervals. So if the start time is greater than okay. If the if the start time is greater than the end times, so we would need to um, swap the two start time and end time. So
But keep in mind, if you're writing it here, the list is already sorted, right? Like the list is already sorted based on the first index of the interval.
so,
Which might
so
be
what
which might
if
be
I
okay, but
have
I'm just letting you know
another?
that that's not what we described before.
Okay. So what if I have another for loops to iterate through the each of the interval in the list, and then we check if the um, start time is greater than the end time, then we just um, swap the end time with the start times and then sort them. Um,
Yeah, that sounds like
how
that will
does
work.
how does that sound to you? Yep. So if we have just so for interval in interval list, we need to check if the first interval the start time is greater than the end times. We will swap them. Okay. Um, this okay, when we swap them,
Yep. So how are we feeling now?
um, so since here, I think this would work for this K, but if we go to the next intervals, um, when we swap them, and I think we would continue with the loops, right, to check for the next interval in the interval list.
Yep, that's what we should do.
Yeah, yep.
Okay.
Um,
Does anything else need to change, or is that going to be
yep.
correct now?
We swap them and then we continue. And then, so in this case, we swap. Yeah, I think this would be this case. So when we swap the end time with the start time, we need to sort it, right?
Yeah, so you're still sorting it, so that hasn't changed.
So we sorted them.
Yeah, I think it's correct. Do you have any other concerns?
Yep.
Okay.
Nope. Would you like me to go over the time and space complexity?
Yeah, let's do that next. Go ahead.
So for the times complexity, it would be n log n, and n is the number of interval in the interval list. And then for the space, we would have this can be O of it would be O of n. Then we need to store the merge interval. So in this case, this for loops would be on, and then since we sorted, so it would be n log n for the sort.
Okay. What about?
Yep. So the over.
What if we had an optimal situation of the input where all of the intervals combined into one interval at the end? What would be the space complexity there?
So you said if we have all of the interval, merge them into only one merged interval in the end, right? And then we just return that.
Yes. What's the space complexity?
Space, I think it would be O of 1 in that case.
Okay. And can you explain quickly why the BO1?
I think since if we have that merged into all, then I think we sorted in place, and then we don't use like any extra data registers to store for the output. So this will be one in that case.
Okay. That sounds good to me then. All right, let's move on. We have some time still, so I want to move on to one more question that we can try our hand at, and then we'll do some analysis at the end. How's that sound?
That sounds good to me.
Let's move on. So let's go to the bottom of this. We'll just make a new function, and we'll just continue from here. So this is the next question we'll be talking about, and in this question we'll be talking about trees. Okay. So first of all, let me just copy the trees. No, we're not in the right language. Let me copy that over. So let's say we have this tree for your reference. And in this problem, I want you to retrieve me a list of all nodes that are distance t from the root.
Retrieve a list of all nodes that are distant. Oh, can you repeat the questions again?
Yeah, so I want you to write me a function called retrieve nodes, and it accepts a root, which is the root of a tree, and then it returns a list of nodes that are distance k, which is an input to the function, from the root.
are distant k from the node to the root. Okay. Okay, so we need to retrieve a list of all nodes that are distant k from the node to the root. So the first questions that I have is that so this would be um a binary trees or it would be a binary search tree.
Does that matter?
Um,
Like, what if it's one or the other? Does that change?
I because since the binary search tree, the current node values, so everything to the left of the current node values, it will be less than the current node value, and everything to the right of the values is will be greater than that node value. So
Yes. Yes, that's true.
yeah.
But you notice in my problem description, I said nothing about the value of the nodes.
Oh, okay. Um, so okay, let me just enter the drawing mode here to visualize the tree.
Yep, I'm having a look.
So if we have so what if we have the first node with value 2 and then we have another node over here, this would be 3, and then would be fine this case. And this would be this would be, for example, this would be 1. So you want me to retrieve the list of all nodes that are distant k from the node to the root.
Yep.
So the distance would be the path from the root to all of the node, right? So it would be from the root to the leaf node, right? This would be here to here.
Yep, that's a distance of 2.
Yep. So if that's the case, then we will have distance up to okay. So here, if we go in this range, in this right subtree, we will also have the distance up to. But one more case is that what if the tree is scaled to the left or scaled to the right? Oops. So in this case, we will have the values. So the distance of the root to the leaf node, it would be, so in this case, it would be 3, right? If that's correct.
Oh, yes, that's distance 3.
Yep. Okay. So, we return a list of nodes that k distance from the root to the north. One way I'm thinking is that we can do like a DFS approach. So we can start
Okay.
traversing
I like BFS. I think
from,
BFS is the right way to go.
yep, yep. So we can start traversing from the root to the lymph node, um, and then we need to check. So I think we'll have to have a distance variable. So it's either can be DFS or BFS. What if we can like also traverse like level by level from the root to the next level, which is the level with the, so this will be 3 and 5, and then we traverse through the next level. Then we have 1, 3, and 4. So yeah. So which approach that you think is it would make more sense? Like this would be DFS or BFS in this case?
Either one would work, but I would recommend going with BFS.
BFS, right?
Yeah, but both would work. But I recommend
Okay,
BFS.
okay, okay. Let me just go back to the code here. So we would have a function called retrieve nodes. It would take in the root.
And an integer k.
Integers k. Okay. So for first we would need to check if the root is none or not. So if the root is none, we just returns an empty list, right?
Yeah, that's fine. Yep.
Yeah. So we use BFS. So I think we would have the queue,
Okay.
initialize the queue first, and then we just append the current node to the current root node to the queue. And
Is there anything
then
else you should append with a root?
oh, then we have the k
Yeah.
the k distance
That
also.
would be good to put on.
Okay, so it would be the root with so with the distant k, so the distant k I think first it would be 0, so it would be 0 initially, right?
I mean, you can count up or you can
So we
count down. That's
start
up
at,
to you.
okay, let's start the root. Yep. And then so we have the current north and the distant. Pop left. First it would be initially at 0, and then we iterate through the queue while the queue is not empty. So the current north we have with the distance, we pop that.
Okay. Yeah.
If we go, yep, if we go level by level, so we have another variable. It's called level size. level size. So in this case, in the example, we have so the first level would be the root, the second level would contain 3 and 5. So let's say the current size of the next level is 2, right? But how
I
can
don't think
we?
that's correct. The level size is not the
Mm,
size of the queue is not the size of the level.
oh,
Unless I'm not understanding your implementation,
yep.
but usually that is not a correct assumption.
Okay.
Why do you care about the level size?
Then if because we're at the root, right? And our current distance is 0. When we pop the root out of the queue, so when we pop the 2 out, then we will need to check the children of the 2, the left children's and the right children's. If the left and the right subtree is not none,
Yes, I agree with that. But why do you care about the level size?
so let's say ours. So now, let's say our queues we would have 2, right? And
No,
then
you would have popped it off now, right? So it'd be nothing.
this would be nothing. So when we if we have the level size, because from the root to here, from the root to the next level, when it's go to the next level, we will need to increment the distance to 1, right?
Yes.
And then from here we go to the if not, we would need to increase the distance also to 2, because we need to return a list of all the nodes,
Yeah, so you're on the right track, right? We don't need the level size. So you're right in that every time we on queue a node, we want to increase the depth, right? But you have the depth right here, the distance. So every time you push onto the queue, just push on distance plus 1. So why don't you get a pointer to the left and round child right now?
So if I have a pointer to the pointers, can you repeat again?
Yeah, sure. So for every given node, you want to push the left and push the right.
Yep.
Right. So do that.
Push the okay. If we have push the left and push the right, right? So if the left subtree is not none, then we would need to and
Whoa. What's the val doing? Hold on. What's the val doing there?
Oh,
right. Your queue appending curve.
current left. Yep.
Okay, and then with this, wait, hold on here. You're appending a tuple. Right. The type is not right here.
Oh. Yeah.
Okay, so the first element of the tuple is the root. What is or the not root a node? What is the second element supposed to represent?
So that would be distance plus distance plus 1.
Good. There you go. And do it for the right node too.
Yep. So we need to check if the right subtree is not none, then we just into the queue the current node, right? distance. Oh, yeah, distance plus 1.
Okay, great. So what if the current distance equals k?
What if the current distance equal k? Let's say if we have, so k also equal to 2 now. K also equal to 2. The distance is 2. Now we need to retrieve or return all the nodes that are k distant. How are we gonna do that? I think we will need to check if the current distance equal to k. If it's equal to k,
That's right. If it's equal to k, what do we do?
we need to return all of the node. In this case, in the example, it will returns. So now it needs to return 1, right? We return 1. And then it will returns 3, 4. Oh, let's wait. So since it's level by level, to return 1, 3, 4, and then 3, 5, and 2. Is that correct? So the list of alternate k distance, this will be 1. Since there one node that is known, and then 3, 4, 3, and then up the next level it would be
It would just be 134.
oh, it would just be 1, 3, 4, which is the last level.
It's level 2. It's level
2.
K.
Yep.
Right. Only nodes 1, 3, 4 are distance 2 from the root.
Okay. So we need to return 1, 3, 4. That means that the last level. How can we return the last level?
Right. So you have distance equals k.
The last level.
Right. Distance equals k. So what does that mean about current node? What does current node equal? Let's say distance equals 2.
Oh.
This is 2. Now what? What is current node?
Distance is 2. Current node is would be 1, right?
Yeah, it would be the 3 nodes at 1, 3, and 4.
It's only 1, 3, 4.
So if distance equals 2, you want current node to be in your returned answer.
Yep.
Okay, so why don't you make a list for your answers? Yeah, there you go.
Yep.
Yeah.
All right. We would need to get the last nodes, the current nodes, and current nodes.
Yep.
Values. If distance equal k. In this case, should it be also like so we just need to return the node, but not the distance k, right?
That's right.
So we don't need to have.
Yep, just a node.
Yep.
And then you can return answer at the end. That's it.
Yep. Right.
Great. Okay. Since we're tight on time, I'm gonna skip the time and space complexity here, and I'm gonna go right into some feedback if that's okay with you. because I think that's going to be a better use of our time. Because I think your time and space analysis is actually really strong, so that's not important for this. Um, cool. So let's just go really quickly into the first problem again, right? The problem of merging intervals. This was pretty well done. I think the main difficulty here was that even though you were really quick to produce a solution for the original, understanding, you didn't realize that of course the intervals could be swapped because I didn't define. I didn't forbid that, right? So that's a valid interval to have the larger number first. I think after you were clear on that one, you were able to solve it. But just keep in mind that that's a pretty common it's a pretty common thing to do, like to have. So don't assume order when there is no order, right? So in fact, you should always, if you see that there's numbers like that, you should always ask, are the numbers ordered in any way? And if they're not ordered, then you cannot rely on them being ordered, right? Otherwise, it would be wrong. Other than that, I think it was well
Yep.
done. But just be aware that yeah, you can assume those kind of things. And then about the second, so before I move on, any questions about the first question?
Um, so not for now.
Yeah, it
Yep.
was a pretty straightforward question. I think it was just a one fault that got you tripped up. All right, so about this binary tree question then, right? So again, right, the key is in the details for the problem statement. Right, in this case, the value of the node is not relevant at all, right? And so,
Yep.
right, because that's the only difference between a binary tree and a binary search tree, and so you should realize that if we don't care about the value, it doesn't make a difference. Now, about the actual understanding here, so I now at the end I realized that you had a misunderstanding about what the return value is, right? And so if you're not familiar with
Yes.
terminology
Yes.
such as distance in a tree, then you should ask that, right? Because I actually didn't know that you didn't know until you gave the example output at the end. And so this is an example also of where it would save you time to write out an example ahead of time. And you actually wrote out the example, you just didn't write the return value. So make sure you actually do
Yep.
that ahead of time because then you would have caught the error earlier on. Okay? So that should be the number one takeaway for this problem. The more technical takeaway I would say is you should familiarize yourself with in general like tree traversal questions, right? Because in this case, I think you set up the queue pretty quickly. That's not a problem, but you were a bit slow to kind of follow that up by figuring out how to add the left and right subtrees and figuring out what the condition is. So that is something which you can definitely practice on and improve to be a bit faster. But I think aside from the misunderstanding at the end there, I think given what you knew, it was still pretty well done. Any questions about the second question?
Um, so yeah, so for this, yeah, I think so. Yeah, so you're saying that I just need to implement the solution. So for the appending the left and right child into the queues, much faster, right? And um,
Yeah. So I mean, what I'd say is that in general, it seemed like you knew how to solve the question once you realized it was BFS, but you were a bit slow to write the BFS actually. Right? I think you were confused about the two parameter nodes on the queue. So clear that up before
mhm,
writing it. And when you start writing it, you should actually just bang out the entire thing first and then figure out what the conditions are. So for example, in this case, you were hesitating to write these two, like these 4 lines,
yep.
right? There's no reason to hesitate there, right? Write the 2 lines out first and then say, okay, what should distance be? What should I be putting on? What should I be putting? Like, what should I be doing? Because in this context, you know, you will always be adding the left, always be adding the right. If they're not null, obviously, right? They're not null. You should check that, and then figuring out what needs to change, right? If you're hesitating, even without even writing that down, I don't know if you don't know BFS or if you don't know how distance works. Like, do you see what I mean here? So, write down
Yep.
what you know, and then think, right? Otherwise, if you know something you're not writing down, then I can't help you. So just be aware of that. Okay, it's a difference. Yeah.
That sounds good to me. Yeah.
Okay, cool. Any other questions about question two?
Um, nope, not for now.
Okay, then that's all from me. Any last minute thoughts? Otherwise, we'll call it here.
Yes. So I want to say thank you so much for your time for the mock interviews, and um, I see you next
Okay,
time.
yeah. Thank you very much for attending. It
Yeah.
was great having you on. Take care.
Take care. Bye bye.